Hello and welcome to Project Pro. My name is Ashay. I'm a data engineer at Deloitte USI, and in this tutorial I'm going to tell you how you can build a PySpark application to process MongoDB data. So that is going to be really fun. So without further ado, let's get into it. Okay, so let's get started and build our PySpark application. But first, before jumping on to the coding part, there are some prerequisites you need to cover first. So you should be having the basic fundamental knowledge for Python programming as well as the ANSI SQL, as we are going to use Python to develop our Spark application, as well as the ANSI SQL to make the use of the Spark SQL API, which will able to submit some simple SQL queries on top of our data. You should also know some of the basic concept of nosql as well as the JSON format, because we are going to use MongoDB in this lecture as a source for our data. And as I hope you know that MongoDB is a document database and stores a JSON-like format, so you should know some basic understanding of JSON. And having the basic shell scripting knowledge is also a plus point. But you should be having the Hadoop HDP Sandbox installed on your PC. If not, I'll highly recommend you to go through the link in the description below to install it, because we are going to use Spark on top of our Hadoop ecosystem, and we are going to store our data file in HDFS, as well as we are going to integrate MongoDB with the use of our Hadoop sandbox. But if you don't have enough space in your PC, you can definitely install Spark, Python, as well as any suitable IDE and the MongoDB, but that will take time. I'll highly recommend you to go and install HDP Sandbox so that it will be easier for you, because MongoDB comes pre-installed in our Hadoop stack and you don't have to worry about any configurations here. So now let's discuss some basic concept of Spark and MongoDB so that we can directly jump on to our development part and build our application. Okay, so first let's discuss about Apache Spark. So PySpark is nothing but a Spark library which is developed in Python and for running Spark application using the Python language. And it will give you all the Apache Spark capabilities. And using the PySpark, we can run application parallelly on the distributed cluster. Distributed cluster means that your workload will be split up and submitted on the commodity hardware running in the backend, and they will do the job very efficiently if we compare it to the single node cluster. So basically, Spark has four main APIs. One is streaming, then we have the MLE for machine learning purpose, graphics for graph computing, and the Spark SQL and data frame. So we are going to use Spark SQL as well as the data frame in this tutorial, because we are going to deal with the structured data as it is a stationary data. It is not coming in real time. So Spark SQL as well as the data frame APIs are pretty suitable for us. And we are going to use Python for this tutorial, because why not? Everybody loves Python and it's a pretty simple language if you are just getting started and highly readable. So that's what about Spark. So to sum it up, Spark is a data processing tool which can be run in a distributed cluster and used to process the big data. And you can use PySpark library as well to develop your applications in Python. Now let's discuss about what is MongoDB. So MongoDB is nothing but a NoSQL and a document-based database, and it stores the data in a JSON format. So if you know about JSON, MongoDB's format is also similar to JSON, and that format called as BSON. As you can see in this snippet here, this is like how MongoDB stores its data in the collection. So let's discuss about what is collection and the structure of MongoDB. The first structure will be the database. So hope you already know that it is a physical container for each collection, and each database gets its own set of file on the file system. And a typical MongoDB server can have multiple databases. So it is a similar of what you know about the relational databases. Then comes the collection. So you can relate collection to the table in a relational databases. Just the naming convention is different. So collection is just like a table in a relational database. And this collection can exist within a single database. But the main thing is it does not enforce a specific schema. You can add as many of the columns in your data and it will not make any difference. If you have like 5 columns in one document as well as 3 columns in another document, and these documents can be stored in a same collection. That is the reason NoSQL databases are pretty popular, because they don't have any fixed schema. So in the real world, it is very good to evolve your schema over time. And then comes the document. So you can relate document to row stored in a relational database. So document is nothing but a set of key value pairs. And I have already told you that it has the dynamic schema. And every document has some ID which is assigned by MongoDB itself. and it's a 12-byte hexadecimal number and which can assure the uniqueness of every document, and it is assigned by MongoDB by default to every document, and it acts like a unique key for each document. So that is like a basic introductory part of MongoDB. So it is like a NoSQL database and stores the data as a JSON format. But we can also integrate different file formats to it, and that's what we are going to do in this tutorial. So that was enough talking. So let's jump on to building the PySpark application to process MongoDB data. So this is the data file which we are going to use for this tutorial. So as you can see, it has the user ID field, the age of that user, the gender of the user, then its occupation, as well as the zip code where that user resides. So this is the data of the users who have submitted some review for a particular movie. So this is like a movies data file which we are going to use for our data analytics purpose. So the first step would be you have to first ingest some data into MongoDB using Spark. So we are going to use the data frame writer to write the data into MongoDB, and then we are able to get to read the data back from MongoDB and do some analytics on top of it. So we are going to also read and write both operation on top of this data file. So this will be really fun. So the first prerequisite, just make sure that you have the Hadoop HDP Sandbox installed. It's a very simple procedure and it will only take half an hour to set up, and you can learn so many technologies because Hadoop Sandbox comes pre-installed with about 30 technologies. So you can work with either Cassandra, MongoDB, HBase, etc, etc. So it's up to you. If you wanna set up individual services in your local system, that is also fine. But HDP Sandbox will be way more easier. So let's jump on to see how to set up HDP Sandbox for this tutorial. So if you are enjoying this video, I'd really like your feedback. It will really motivate me to make such content for you. So please leave a comment below, or else if you have any doubts, you can also ask me in the comments and I'll get back to you as soon as possible. So to kick off our sandbox, you just go to the Oracle VirtualBox and start the service. So I have already kept it in running condition to save some time, and it will hardly take 15 to 20 minutes to kick off all the services. So this is how it looks like. So this sandbox is in running condition now. So now you can go to Ambari and check if all the services are running fine without any issues. So to log in into Ambari, just you have to go to the local host 8080 port. On that is the port where Ambari will be running. So 8080, that's it. So this is the sign in page for Ambari. So I have already logged in as an admin user, but let's sign it out. So in this case, you have to log in as a user Murray_dev. So this Murray_dev is provided by the Cloudera itself. So we are going to use that. So the password would be also the same. So just give Maria_dev and the password would be Maria_dev. Just log in into that, and as you can see, all the services are running fine without issues, and we are going to use the MongoDB for this tutorial, and we have the MongoDB service running without any issues. So we don't have any alerts. Okay, so let's get started and build our PySpark application. So I'm going to use VS Code. You can use any editor here. So what we'll do is we'll just create our script here in the editor. We are going to upload it into the HDP Sandbox on our Linux server, and then we will kick off using the Spark submit. So let's get started with our coding part. So the first thing first, you need to create a Spark session, and you'll be going to need the required packages for your application. So what we are going to do is from the PySpark.sql, you are going to import the Spark session. That is like the fundamental step. You need Spark session to use all the methods to process your data. Then again, we'll be needing the row because our file is not a comma separated or a JSON format file. It is a text file which is delimited by the pipe characters. So first we need to build the parser function here and we have to pass it on top of our RDD to apply the structure for it. So for that you have to import from PySpark.sql, you have to import the row. And after that we are going to use the functions as well. So from PySpark.sql, you have to import the functions. That's it. These are the packages you need for your application. The first step would be you have to make one function which will take the line as an input, and it will just split your line into the different fields, and you have to pass the parameter in the split function. So you have to define a function here. So let's say we have parse input, and in this function it will take line as an input. So the line from our data file will be the input for this function, and the fields will be the pipe limited. So we have the fields variable, and we will going to use the split function on top of the line, and split it using the pipe character, because our file is delimited by the pipe characters. And this function will return the different fields. So what we are going to return is the row, which is a function, and we will be needing the different columns for our file. So the first one is user ID, which is of a integer data type, and it is like a first field, right? So you have to pass it the index 0. If you know Python, this will be like the piece of cake for you. The next one is the age, which equals to the integer. It's again the integer because age is usually stored as an integer unless you have the null values in your file, and it is situated on the second index, which is first. Then we have the gender, which is equal to third field, so just pass it as the second one. Then we have the occupation of that user, which is like fourth one, and then we have the zip code. We'll call it as zip, which is again the fifth one. So there you go. This is your function which will take line as input and give us the row with all our headers, which are user ID, age, gender, occupation, and the zip code. So this part is done. We have to pass this function in our RDD using the map method. The first one, you have to create the Spark session now, because for every Spark application, Spark session will be the entry point for you, and Spark session will submit the job on the Spark driver, and Spark driver will communicate with your resource manager and submit your job into the worker nodes, which is like the Spark executor, which are installed on every worker node in your cluster. That is a basic fundamental thing, and you should really know that. So if you know distributed computing, you know what I'm talking about. So first thing first, let's create a Spark session. So we'll call it as Spark, and in Spark we got the Spark session dot. On the next line, let's build our Spark session. So we are going to use the builder method. So every Spark session will take the builder method to build a Spark session, and let's call it as, you have to provide the app name for your Spark session, and here I'll call it as Mongo Spark, because why not? We are going to integrate Mongo with Spark, so it's pretty straightforward name. Then on the next line, you have to use the get or create method. So get or create will get the already created Spark session or create a new one for you. So get or create, that's it. This is your Spark session. So once you created the Spark session, you have to build your RDD and pass this parser input function to apply the schema to it. But first, our file should be situated in the Hadoop file system. So that we need to first do, then we can build our RDD on top of that specific file, which is situated in HDFS. So now let's go to Ambari, go to file system and upload that file. So this file is situated in a GitHub repository. So I'm going to give all the links to these files as well as the script. So it will be a very hassle-free for you to kick off your application. So you can just download this file in your system, and then we can definitely go and upload it on the HDFS. Okay, so this is our Ambari, and all the services are running fine, so don't worry. So you have to go to this one and the files view. So in the files view is nothing but the HDFS. So the HDFS test is passed. So first you have to go to this user folder, and in user you have to find your user. So we are logged in as a Maria_dev. So here is the Maria_dev, and here let's create one folder. So we'll create a new folder here, which is called it as MongoDB. Okay, so let's add this folder, and in MongoDB let's upload our file. Okay, so just here is the upload button. You can upload the file, you can drag and drop as well as select your own path. So here I have it saved in my C drive and in the Spark course folder, and this is the movies.user file. So you just have to open that file. Okay, so there you go. This file is uploaded to our HDFS. You can do that through command line itself, and definitely I am going to give all the commands as well in the description below, so that if you don't have access to Ambari, you can do that using the PuTTY terminal or any other command line tool you can use to communicate with your Linux box. So this file is situated in user, then Maria_dev and the MongoDB. So you have to just remember this path, because that's we're going to use to create our RDD. So you have the movies.user uploaded. Okay, so just jump on to our code now. Okay, so let's build the RDD. So for building the RDD, you have to give any name here. So I'll give it as lines, and you have to use the Spark session to create the RDD. So all you have to do is use the Spark, which is the Spark session, and the Spark context here. So Spark context dot, the method is text file, because that is our text file on top of which we are creating our RDD. So here is the text file method, and in text file you have to pass the path to your data file. So here, as you can see, our file is situated in the HDFS. So you have to give the HDFS here so that Spark will know that you are referring to some HDFS path, then // then your file is situated in user, then you have the Maria_dev, then we have created a MongoDB folder, so you give like MongoDB/movies.user. So this is our data file. So that we have created the RDD now. On the next line, we have to pass the parser function because that file doesn't have any header. So Spark will not know what will be the column names and what are the data types for those specific column. So this parser input function, we have to pass it in the map function of RDD to apply some structure to our RDD. So that is very important. Okay, so let's create another RDD users and we are going to use the lines.map method, pass our parser input function. So all you have to do is pass the parse input here and that's it. Now you have to convert this RDD into the data frames because why not? Data frame is a pretty powerful structured API and it takes the advantage of the Spark SQL engine which contains the Catalyst optimizer as well as the project Tungsten to optimize your workflows. So RDD is pretty like obsolete and no one uses it, but for a better understanding, we are covering both RDD as well as the data frame. So once you have your RDD ready, we are ready to convert it into the data frame. So we will just call it as user dataset and we are going to convert it into the data frame. So we'll use the Spark session dot create data frame and in create data frame you have to pass your RDD. So these users we are going to pass it under here and that's it. Now you have to write this data frame into MongoDB because our MongoDB doesn't have any data. So if you have data already lying around in your MongoDB, then that will be very helpful because we will be not going to write any data to MongoDB. We can directly read it back and do our data analytics. Okay, so on the next line, you have to write the data in the MongoDB. So here we are going to use the data frame writer method. So all you have to do is we have the user dataset, which is our final data frame dot the write method. And here all you have to do is use the format. So format is pretty important here. So we are not using any native format to Spark, which is Parquet, Avro, ORC, etc. etc. We are going to use the MongoDB's format. You have to just mention the com.mongodb.spark.sql.default source. That's it. So this is the format of the MongoDB for the Spark data frame. So if you have to write any data frame to our MongoDB, you have to use this format. So you have to remember that. On the next line, you have to give the URI for your MongoDB. So our MongoDB is running on to the 127.0.0.1 server. So that port name you have to pass to able to communicate it with the Spark. So you can do that in the option method. So in the option, all you have to do is provide the URI and the URI is MongoDB://127.0.0.1. Now you have to provide the database and the collection that you want to create. So all you have to do is movies data maybe dot user. So that is the collection name and the movies data will be the database name. Okay, so on the next line, you can give the mode as append. So you can also use the override method. It totally depends on your application. So for example, let's use the override method here. So it will act as a full load in your MongoDB collection. So all you can do is like the mode and in mode you can pass it as override. That's it. And after that, you have to save your data frame. So to save the data frame, go to the next line, the save. So it will just save your data frame in the MongoDB collection. So that's all you have to do. So now you have the data loaded into the MongoDB till now. So once you load the data into MongoDB, you need to able to read that data. And after that, you are going to able to do some analytics on top of that data. So in this example, we are going to use the Spark SQL API to able to create a temporary view on top of our data frame. And then we can use ANSI SQL language to submit some simple SQL queries on top of our data. So are you ready? Okay then. Okay, so for reading back the data, let's create another file. And here I have already imported all the modules as well as created the Spark session because that will be a very similar as the previous code. So all you have to do is you have to read the data back from MongoDB. So to do that, just use the data frame reader to convert your collection into a data frame. So all we can do is give the name to our data frame. So read users equal to, you are going to use spark dot read method, and on the next line you have to provide the format for it. So the format will be pretty similar to what we have seen in the previous code. So you have to just go to it, and yeah, we can give the same formats. And again on the next line you have to provide the option for the URI where your MongoDB service is running. So again that option will be like the similar to our previous code. So just you can go and copy that whole thing, because okay, so once you have the URI and the option, all you have to do is use the load method, and there you go, your data frame will be ready for data analytics. So you can just go and see as load. That's it. That's all you have to do to create a data frame. But what about the analytics? So once you created it, just we will get the schema for it. So read users dot print schema to get the metadata of our file. Okay, so once you got the schema, we will use the Spark SQL API to submit ANSI SQL queries on top of this data frame. So all you have to do is give the read users dot create or replace temp view. So this will create a temporary view on top of your data frame, and this temporary view does not hold any data. It is just a temporary view which is only tied to your Spark session. So once your Spark session will be terminated, this view will also vanish and it will not take any space on your system. So that is the power of creating temporary view or table in your Spark application. So just provide any name here. So we'll provide a name as users. Why not? So once you got the view users created, we can directly submit ANSI SQL queries on top of it. So all you can do is you can do SQL df any name here. We'll create another data frame, and we will use spark.sql method to submit our SQL queries. So I'll use the multi-line comments here. So here we are going to select the occupation and number of rating that users with a particular occupation has submitted, so that we'll get to know which occupation watches the more movies. I'm just kidding. That is not a big data set, but you will get some insight out of it. So what we are going to do is we are going to select the occupation and the count of user ID of that occupation from the view. So our view is users, and let's give some names. So I'll give it as CNT underscore user, and we are getting the data from the users, and we are going to use the group by to group our data as per the occupation, and we are again going to use the order by the count user, so that you'll get the more popular ones in the first place. And that's it. And you can just directly use the show method on top of it. So you'll use SQL df.show to get the data into your console. So once you submit this application, it will just create a data frame on top of it, then it will create a temporary view, and it will give you the result of your ANSI SQL query in the console itself. So that will be pretty fun. So our both files are ready. All you have to do is you have to just download it from our GitHub repository. So I have already uploaded them. You can use the wget method in your putty command to download 2 scripts in our Linux box. Then we can use the Spark submit, and the only argument we need to pass is the Mongo Spark connector. That is a mandatory for this application. So without further ado, let's jump on to that. Okay, so once your both scripts are ready, you can just open the putty terminal, and you have to log in as a Maria_dev. So I'll just give you the host name. So the host name would be Maria_dev @localhost, and we are running on the port as 2222. So that will be your credentials for the Maria_dev Linux box. So just you can click on open, and here again the password will be same, Maria_dev, and that's it. We are logging into a sandbox. Okay, so you just have to get our codes ready. So all you have to do is use the wget command, and you have to just give the path for it. So I am going to give you all these commands and links in the description below, so you don't have to go through any hassle. So give it at https://raw.github/usercontent.com/ashaypatil11, which is my username, /hadoop, which is the repository, /main branch, /the mongo write.py. So this is the file which is going to use to write the data into MongoDB. So just hit OK. And that's it, the file is downloaded. So again you have to go to the same command and give it as mongo read.py. So this is the file which we are going to use to read back the data from MongoDB. So that's it. You are ready to kick off your jobs. But first, let's peek into the file and see how they looks like. So I'll first use mongowrite.py. So I'll just use the VI editor here and see how it looks like. So this is the pretty similar stuff. We have imported all the packages, then parser input function, as well as created a Spark session, and that's it. And again, we can use the VI for getting the Mongo read. So it is also the similar one. So we have imported the modules, created the Spark session, created data frame, and then we have created the view and given some ANSYS SQL query. So it is a similar code which we have just discussed. So all you have to do is kick off your Spark job using the Spark submit command. But first you have to export the Spark version first. So you have to use the Spark version 2 because HDP Sandbox will come with 2 versions of Spark. But in this case, all you have to do is use the export method and give like Spark _ major _ version, and you have to set it as 2. Okay, so I guess I have taken extra space here, and that's it. So all you have to do is use the Spark submit command. So give like Spark submit, then you have to give the packages here. So that is the only argument you need to pass, and the file name. So this is very important. So this you have to pass the Mongo Spark connector, which is situated in the org.mongodb.spark to able to integrate your Spark with MongoDB. So all you have to do is give org.mongodb.spark, but before that you have to provide the packages, and this is the package name. So org.mongodb.spark : mongo-spark-connector _ the version 2.11 : 2.3.2 and your file name. That's it. So your file name is mongo-write.py. So that is the file which we are going to use to write the data to MongoDB. So just that's it. Or that's all you have to do. If everything looks good, just execute it. So as you can see, your job is running now. It is submitted to the cluster. And there you go, it is running the job. It will take some time to check it off. And there you go, your job is successfully completed. So to verify it, we can just go to the Mongo shell to verify that our collection is already created. So we'll go to the Mongo shell. So just type like Mongo. And that's it, you are in the Mongo shell now. So you can just give and show the databases. So give like show databases. So I'll just forgot the S here. So as you can see, the movies data database is present here. So we'll again use the use method. So just give use movies data. That's it. And we have switched to the movies data now, and we can just go to and give like show collections. So just give show collections. And as you can see, our users collection is created. So we have successfully written the data from Spark to the MongoDB. Okay, so now you got the data. We can use the exit here, and we can just kick off our next file, which is mongoread.py. So again, to submit your job, you can use the previous command. Just you need to use the different file here. So you can just give like mongo-read.py. That's it. That's all you have to do because it uses the same package and also the same command, which is Spark submit. So just execute it and see what happens. So just hit enter. So it will just take time to check it off. So it will take the already created Spark session. So as you can see, we got the print schema here. And there you go, our job is still running. And that's it. Our job is completed now, and here are the results. So as you can see, it got you the occupation and the count of users that particular occupation has and submitted the ratings in your movies dataset. So as you can see, there is no brainer. Student has submitted the most ratings in our movies dataset because that makes sense, right? Students will watch more movies than any other database. We got the other here because some people will not give you their occupation. I don't know why, but here are the numbers. So that is not relevant, but I'm surprised to see educator here has a 285 entries. So teachers also watches movies and submits the ratings for the movies. And we got the engineer because why not? And we got the homemaker at the last. So that will tell you that homemaker has a lot of work than any other occupation in the world, because from this data set only submitted 21 ratings. So I'm just kidding. This is just for fun. I hope you got some insight from this file. So that is the main task of every data engineer, that generating a value from your big data and provide the business some meaningful insights out of it. So that is all we are going to cover in this tutorial. I hope that you have understood the basic concept of Spark, MongoDB, and how we can read and write and integrate these both services to provide a data solution. So don't worry, I'll be giving you all the commands and the resources required for building this application, and you will be able to do it in a short amount of time. And if you face any difficulties or face any errors, you can let me know in the comments and I'll get back to you as soon as possible.